Does China really need to wait until its sixth-generation fighter enters service to surpass the US in air power? This seemingly distant topic is sparking increasingly heated debate after US military media outlet Military Observer crunched the numbers. Its core argument points to a critical fact: China's J-20 production rate has already surpassed that of US fifth-generation fighters, and this gap in production capacity is quietly reshaping the balance of air power between China and the US currently. The US possesses two fifth-generation fighter models. Production of the F-22 has long ceased, with a fixed production run of 195 units. As for the F-35, the US's only fifth-generation fighter currently in production, total production reached 1,000 units by September 2025. However, only about 500 have been delivered to the US Air Force, Navy, and Marine Corps, keeping the total number of active-duty fifth-generation fighters at around 700. In contrast, while China's J-20 fleet remains smaller than America's, it is expanding rapidly. External estimates of J-20 production range from conservative projections of over 200 aircraft to more aggressive figures approaching 400. More critically, the production capacity comparison reveals a stark contrast. J-20 annual output is estimated at 50 to 70 aircraft, potentially exceeding 100 units. Meanwhile, F-35 production has declined from over 140 units at its 2022 peak to 68 units in fiscal year 2025, with actual deliveries potentially dropping to just 48 units due to Tier 3 technology upgrade issues. The situation worsens in fiscal year 2026, with F-35 procurement reportedly slashed to just 24 units, a stark contrast to the J-20's stable, high production rate. The decline in F-35 production stems from multiple challenges facing the US. First is funding allocation. Despite a $900 billion defense budget, resources are spread thin across major projects, like the Sentinel ICBM, Constellation-class frigates, and sixth-generation fighters, squeezing F-35 funding. Second are inherent design flaws. This aircraft, designed for tri-service use, fails to fully satisfy any branch. The Air Force criticizes its stealth performance and maneuverability, while the Navy finds it unsuitable for carrier operations, with even the newest Ford-class carriers struggling to effectively catapult the F-35C variant. Furthermore, the F-35 suffers from exorbitant maintenance costs, with hourly operating expenses reaching $36,000, far exceeding the initially promised $18,000. This has prompted U.S. Air Force officials to state they wouldn't drive a Ferrari to work every day, implying the aircraft won't be deployed for low-end missions. More concerning is that U.S. Department of Defense documents reveal over 800 design flaws in the F-35, ranging from engines and ejection seats to airframe materials, causing persistent delivery delays. Facing the F-35's predicament, the U.S. has pinned its hopes on the sixth-generation F-47 fighter. According to information disclosed by U.S. Air Force Chief of Staff David Orvin in May 2025, the F-47 will boast a combat radius exceeding 1,000 nautical miles, significantly surpassing the F-22's 590 nautical miles, and will feature Stealth++ level stealth capabilities with an anticipated flight speed exceeding Mach 2. The U.S. Air Force plans to procure over 185 F-47 fighters, beginning replacement of the F-22 fleet in the 2030s. The F-47's true game changer lies in its human-machine synergy combat model. Each F-47 will command 4 YFQ-4 YFQ-44 drones, forming manned aircraft plus unmanned wingmen aerial formations. These drones can serve as decoys to absorb enemy missiles, carry electronic warfare equipment to jam adversary radars, or even launch suicide attacks. The U.S. military plans to procure over 1,000 such drones to counter China's saturation strike capabilities through low-cost attrition warfare. However, the F-47 project faces three major challenges. First is funding. The Trump administration announced an 8% annual defense budget cut, while the F-47's total development cost is projected to reach $50 billion, averaging $300 million per unit. If production proceeds as planned for 414 units, total expenditure would exceed $100 billion. Second is an alliance trust crisis. After taking office, Trump halted weapons aid and intelligence sharing with Ukraine, exposing the U.S. installation of a kill switch on F-35 fighter jets. This has made allies cautious about jointly developing the F-47. Third is technological uncertainty. U.S. military observer Zhang Zufeng notes that Boeing has not developed a completely new fighter jet since the 21st century, casting doubt on its technical capabilities. Moreover, the F-47's canard configuration, suggests the US lacks sufficient technological reserves for 6th-generation fighter development. In contrast, China's 6th-generation fighter development appears more robust. Both of China's 6th-generation prototypes have undergone frequent test flights, featuring aerodynamic configurations that evoke a distinctly sci-fi aesthetic. More importantly, China maintains a complete aerospace industrial system capable of supporting the development and production of complex weapon systems. Currently constrained by environmental factors, the Chinese Air Force cannot fully leverage the J-20 size advantage over the F-35. However, by 2035, shifts in the international landscape will pose significant challenges for the US F-47 seeking to globally confront China's 6th-generation fighters. In contrast, the US aviation industry faces systemic challenges. Recognizing this, the US Navy insists on developing the 6th-generation F/A-XX heavy carrier-based fighter. However, Northrop Grumman must simultaneously develop the B-21 and the F/A-XX for a maximum order of 300 aircraft, casting a grim outlook on the project. Compounding the Navy's concerns, the next-generation AIM-260 air-to-air missile, designed to counter AVIC's rapidly advancing long-range air-to-air missiles, has also encountered delays. Originally slated for $1 billion in guaranteed production funding by 2025, the program now faces setbacks. The J-20 not only holds an advantage in production efficiency, but also boasts highly recognized individual performance. U.S. military observers believe the F-35's single-aircraft air combat capability falls short of the J-20. With a fuselage length of 20.3 meters and a wingspan of 12.88 meters, the J-20 is estimated to reach a maximum speed of approximately Mach 2.0 and has an operational radius of about 2,000 kilometers. Equipped with a gallium nitride active, phased array radar and paired with medium to long-range air-to-air missiles like the PL-15 and PL-17, it achieves a first-to-detect, first-to-strike combat capability. The J-20's canard configuration with lift body winglets creates a distinctive profile, seemingly combining low visibility with maneuverability and range. Coated with radar-absorbing materials, the J-20 is considered to possess exceptional stealth capabilities. More significantly, the Chinese Air Force is actively integrating the J-20 into a sophisticated combat ecosystem through seamless coordination with early warning aircraft, ground radars, long-range missiles, and command and control nodes. It is building a closed-loop operational chain encompassing detection, command, strike, resupply. Such systemic combat capabilities often prove more decisive in determining battlefield outcomes than individual aircraft performance. If the J-20 proves as adept at intercepting high-value targets like aerial refueling aircraft and AWACS as it appears, it will pose a serious challenge to the global operational capabilities of U.S. air power. The competition between Chinese and American air forces has transcended simple numerical comparisons, entering a comprehensive contest encompassing production capacity, technology, systems, and innovation capabilities. The U.S. Air Force not only faces declining production capacity for fifth-generation fighters, but also an aging fleet. In fiscal year 2025, it plans to retire 250 military aircraft, while procuring only 91 new ones. A retired U.S. Air Force three-star general even warned that cutting F-35 procurement would create a significant capability gap, noting that the U.S. Air Force is currently operating the oldest, smallest, and least combat-ready fleet in its history. In stark contrast, the Chinese Air Force maintains a significantly newer fleet, with a much lower average age than its U.S. counterpart, boasting superior operational readiness and combat effectiveness. If current trends persist, China's J-20 fleet could approach, or even surpass the total number of U.S. fifth-generation fighters by 2030. While external claims of 1,000 J-20s in service by 2030 seem unrealistic, military observers' assessment likely stems from this trajectory. China may surpass U.S. fighter capabilities without waiting for sixth-generation aircraft. Yet the race for air superiority never ceases. The U.S. is accelerating its F-47 program to reclaim technological leadership, while China actively tests its own sixth-generation aircraft. Who will dominate the skies of tomorrow hinges not only on production line efficiency, but also on the holistic synergy of a nation's industrial foundation, technological innovation systems, and military strategy. In this quiet aerial race, the scales appear to be tipping toward the east. Yet this contest for future air supremacy is far from over.